Hello, class. So this is the first lesson on differential equations. So we're starting on chapter 1 here. So we're going to start very general. We're just going to start defining what a differential equation is and then talking about some of the properties of differential equations that we're going to be looking for. So we'll start with the first part. What is a differential equation? So a differential equation is just an equation involving derivatives. So a very simple definition and very general. So for example, we have an equation like this. This is a differential equation because it basically satisfies the two properties that we're looking for. Right? So first off, it has to be an equation. Right? It's called differential equation. So you have to look for the equal sign. And then second, it has to involve derivatives. So there has to be some derivative somewhere, potentially more than one. And of course, here we can see that there's a derivative right here, right? dy dx. Okay. So a very simple differential equation, but a differential equation nonetheless. Now, this is a very easy definition. So you can see that there's a lot of equations that would match this criteria. In this class, we're going to kind of limit our scope to specific types of differential equations. And that's why this, I guess, video I'm titling Properties of Differential Equations. Okay, so that's the first part. What's another example of a differential equation? Well, you could have something like, let me change color. You have something like third derivative with respect to x of some function plus, say, I don't know, 3 times dy dx equals x plus 1. Again, this is a differential equation. Why? Well, first of all, it's an equation. There's an equal sign. And then second, there are derivatives involved, right? There's the third derivative of some function y here, which we don't know what y is, right? But it's some function, and we're taking its third derivative. Right? And then we also have its derivative here, just this regular first derivative. And this is a differential equation because it's an equation involving derivatives. So the two conditions are satisfied. Okay, so a very easy definition. Now, usually when you have an algebraic equation, so something like, so an equation like 2x equals 1, a lot of times you're told to solve the equation. What does it mean to solve the equation? Usually means to solve for x. So here, I'm going to use this symbol, which I'm going to be using a lot in my lectures. This symbol here, which is like an arrow, but instead of just one horizontal line, there's two of them. This symbol, it basically just means implies. Okay. Again, I'm going to be using this all over the place. So the fact that 2x equals 1, what that implies, or we can solve for x, and this means that x equals 1/2, right? Just divide both sides by 2. So that's what it means to solve an algebraic equation. Now, for us, solving a differential equation is going to mean something different. So let's go back to the differential equation we had before. Okay, so here it says, example 2, find a solution for the differential equation in example 1. Right? So we looked at two of them. Let's not worry about this one because it's a little bit complicated. Just focus on this one. Right? Let's try to find a solution for this differential equation. So dy dx equals 2. So as I was mentioning in the previous slide, we have this equation involving derivatives of some function, right? In this case, a function y. We don't know what that function is, but we know that in this equation, we're taking its derivative. You know, there's some function y that when we take its derivative, it's equal to 2, right? So dy dx equals 2. So here, the unknown is not the variable, either x or y. Of course, there's two variables, y being the dependent variable and x being the independent variable. Those are not the unknowns. The unknown here, we don't know what's what the piece of information we're missing is what is that function, such that when we take its derivative, we get 2. And that's what it means to solve a differential equation. It means to find the function that satisfies that equation. So when you plug it in, you get an inequality. So let me write it like that first. So a solution to a differential equation, so it's an equation involving derivatives. Now, differential equation, I'm going to be writing that word, those 2 words a lot. So I'm just going to abbreviate it by DE for differential equation. Right? So a solution to a differential equation is a function that satisfies the equation. Right? And then in parentheses, I'm going to write what that means. That means a function that gives you equality when you plug it in. And I'll show you an example with this differential equation that we have. Okay. So now the key thing here, and again, as I was explaining, is that solutions here are not variables anymore. So variables, you can consider them as functions, but really we want to make it precise that a solution to a differential equation is a function. And this function can be very simple or very complicated. Right? You've taken Calc 1 and Calc 2, and you've seen that there are some functions that are very easy to work with, like polynomials, and some functions that are not as easy to work with, maybe trigonometric functions or logarithmic functions. So a solution is a function that satisfies the equation, meaning that when you plug it in, you get equality. For example, and let me go here to another slide. Again, we're still working with the differential equation. There's 2. Now, I want to find a function that satisfies this equation. That means a function that when I plug it in, I get equality. Now, one possible function is 2x. So no, y equals 2x is a solution. Why? Well, let's plug it into the equation. So let's come in here. So we're taking the derivative of y equals 2x. So here we're doing d dx of 2x. So we've replaced the unknown function y with the function that we're claiming is a solution, right? So d dx of 2x, and the other side stays the same. There's nothing to plug in there. So if this is a solution, then this must be an equality. What's on the left-hand side of the equal sign has to be equal to what's on the right-hand side of the equal sign. So let's check that that's true. Okay. So let's simplify. What's the derivative of 2x with respect to x? So remember from Calc 1, that's just 2. So the left-hand side is 2, the right-hand side is 2, and that works. What's on the left is equal to what's on the right. So y equals 2x is a solution to this differential equation. Now, a differential equation can have more than one solution. In fact, it can have infinitely many solutions. For example, y equals 2x, let's say, plus 7 is also a solution. How do we check that it is? Again, we just plug it into the differential equation. So d dx, our function y, we're saying is 2x plus 7. So replace the symbol y, which represents the function, by the actual function 2x plus 7. And again, if this is a solution, then what's on the left should be equal to what's on the right of the equal sign. So let's simplify. What's the derivative of 2x plus 7? Well, the derivative of 2x we saw is 2, plus the derivative of 7. The derivative of a constant is 0. So 2 plus 0 is 0. 2 equals 2. So again, we get equality. So y equals 2x plus 7 is also a solution. So this is usually how it works. If you're given a differential equation like I gave you here, it is very easy to verify whether a function is a solution. You just plug it into the differential equation. If you get equality, then it is a solution. If you don't, it is not a solution. So here, something that's not a solution. So let's use another color. So let's use blue. So note, y equals e to the x is not a solution. Again, how do we check this? We just plug it into the differential equation. If we get equality, well, then it's a solution. If it's not, then we don't get, it's not a solution. So here, let's plug it in. So working with the same differential equation. D dx, we're saying that the function is e to the x, and the right-hand side is always just 2. Let's see if we actually get equality. What's the derivative of e to the x with respect to x? Well, if you remember from Calc 1, it's just e to the x. Right-hand side is the same. Is the function e to the x equal to the function 2? No, they're not equals, right? They're two different functions. And so I was trying to erase. So usually if I want to write that something is not equal, I'll write an equal sign with a line through it. That means not equal. So we plug in the function, we don't get equality. What's on the left of the equal sign is not equal to what's on the right. So this is not a solution. So again, if you're given a differential equation, it's very easy to check if a function is a solution or not. Just plug it in, see if you get equality. Now here's an example that's a little bit more complicated, but still the same. So now they're telling us, verify that x to the fourth is a solution to the differential equation. Y double prime, remember that you can write derivatives in two different ways. Right? So you can use this notation, which is the same as saying the second derivative. Right? So number of like apostrophes and the exponent of the y, that's the number of derivatives you're taking. Right? So verify that x to the fourth is a solution to this differential equation. Y double prime minus 2 over x y prime minus 4 over x squared y equals 0. Again, how do we check whether a function is a solution to a differential equation? Just plug it in, and then you should get equality. Okay? So let's plug in x to the fourth here. So we have x to the fourth, its second derivative, right? So just replace the variable function, the variable y that represents the function, with the actual function we're testing. In this case, x to the fourth, right? So x to the fourth, its second derivative, minus 2 over x times x to the fourth prime, right? So the derivative of x to the fourth minus 4 over x squared times the function, which we're saying is x to the fourth. That should be equal to 0 after we simplify it. If it is equal, then it is a solution. If it's not, then x to the fourth is not a solution. So let's simplify. What's the first derivative of x to the fourth? So we could do some scratch work here. So x to the fourth prime, just the power rule, bring the exponent down, subtract 1. X to the fourth double prime, it's just the derivative of this. Again, bring the exponent down, subtract 1. So x to the fourth double prime is 12x squared minus 2 over x. X to the fourth prime, or the derivative of x to the fourth, was 4x cubed minus 4 over x squared times x to the fourth. And again, hopefully this equals 0. So let's simplify. Let me use some imply symbols here. So 12x squared minus, let's simplify, 2 times 4 is 8. X cubed divided by x is x squared minus x, well, 4 times 1 is 4. X to the fourth divided by x squared is x squared. Now 12x squared minus 8x squared minus 4x squared equals 0. So now you can see that indeed the function y equals x to the fourth is a solution to the differential equation. So again, very easy to verify. Just replace the variable y, or the dependent variable, because the variable names might change. And I'm going to talk about that in the next video. I think I kind of ran out of time right now. But in the next video, I'm going to show you that it doesn't matter that the variable names change. There's basically always going to be two variables. A dependent variable, which represents the function, and an independent variable, right? X. Right? So y is a function of x. Now those names might change, but you have to get used to it and realize, okay, one variable is always the dependent one, the other variable is always the independent one. But the point of this is very easy to verify whether a function is a solution to a differential equation. And I'm repeating it a lot just because I want it to really be stuck in your heads. Plug the function in, simplify, you should get equality. What's on the left of the equal sign should be equal to what's on the right. Now, what's interesting is if we're not given what a solution is and we have to find it somehow. Now, that's the interesting part. And that's where differential equations really starts to get hard. So again, it's really easy to verify whether a given function is a solution. But let's say we weren't given that x to the fourth is a solution to this differential equation. We weren't given that. How would we find the function that satisfies this? I think it would be very hard. So again, going one way, going the derivative way, is easy. Given a function, taking derivatives, plug it into an equation, very straightforward. The opposite is going to be hard, but we're going to talk about that in the next video.